and I can compare it to
Welcome to another episode of Stewart Squared, a spin-off podcast where both myself, Stewart Alsop III, and my father, Stewart Alsop II, are going back into the early rise of the personal computing industry, the rise of the internet, and the rise of the mobile revolution to kind of put into context what is happening with artificial intelligence in terms of a sort of a trend that's been going on since the 1980s. And luckily today we roped in Joseph Alsop, my uncle Joseph Alsop, to give some more perspective from a third party on this revolution. And we'll really dial it into programming because it's funny. I'm not sure if you remember this, Joe, but we had a conversation probably about 10 years ago in the car where you said for many decades, people were trying to get artificial intelligence to the place where we could talk in natural language and then have the computer go and do the programming for us. And over the past months, I actually forgot to show you guys. I wanted to show you guys that what I was doing. Now I'm talking in natural language and it's now programming for me. And so it's like took me back to that conversation. So I think that'd be a fun theme. What's your take on that? Or yeah, go for it. That
just the first thing I want to say is that conversation probably took place when Joe was getting married in Germany, because you and I went together to his wedding, and you were the only next gen, I think, person at the wedding.
Oh, really?
Yeah. So that might have taken place then, because I can't think of another time when we would have all been in a car.
Yeah. What do you think about that, Joe? Is that real? Is that an accurate representation of the decade-long experience to get the computer to program for us?
I have a somewhat different take on it, which is that we have to simplify the way we program to the point that whether it's an AI or our own selves, we can tell the computer what to do. I mean, we can tell other people what to do. We can do a lot of things without having to go through this intermediary called a programmer or developer. And that's always been my goal, has been to make it so that whether with the help of an AI or directly because the programming is so easy, people can build their own applications. I mean, the focus of the company Progress was on business applications. So, the kind of things you run a business on. And I'm still involved with a company that's focused on precisely that, to make it so easy. But there's always been a struggle. We sort of made it easier and easier and easier, but we haven't gotten quite to the point where sort of, quote, the man on the street, unquote, can tell the computer what he wants done and
Yes.
have something done that basically resembles what he started out asking it to do.
And this is something they're talking about, autonomous agents. They talk about autonomous agents and they're highly hyped right now, but I haven't seen any evidence that they're actually real. But this is the idea of an autonomous agent that you just tell it what to do, and like a coworker, it just goes off and does that, and then comes back with it done. But that's not the case right now. We still have this.
Yeah, except the time between when you tell it and when it's done is essentially instantaneous.
Yeah.
Right.
Yeah.
Because it's a smart, fast computer backed up with the right kind of tools to interpret what it is you want done, so that there's no need for it to, quote, go off and think, unquote. It can just do it.
So we're still not there yet. We're still go for it.
So before we started recording, we were talking about ancient history and InfoWorld. And one of the memories that I have from InfoWorld is, in the first instance, in what it was, 1984, 83, 84, is we had the back page advertiser the whole time was called The Last One. And The Last One was the last program you'd ever need to buy, because it would do everything for you, including writing programs. It was like, this is 1983. I mean, we didn't have the internet. We had like these tiny little personal computers that were now, in retrospect, very underpowered, and it just didn't work. And it was like they raised a bunch of venture capital, they spent their money advertising it, and just went out of business. And so there's been this desire to use computers to do the things that, both to, relieve us of the burden, and also to do things that are aspirational. And this is why people are so excited about generative artificial intelligence. It's like only now that actually people think it might happen, although you're absolutely right, Stuart. I haven't seen any evidence that that's that helpful. And my test for that is time zones. Time zones are this construct we have of, which is kind of widely shared, but not really because it's different everywhere. Like one of my partners is in India, and India is on 30 minutes.
30 minutes.
It's like,
yeah.
And some people do daylight savings and some don't. And so when you're sitting there trying to schedule yourself to fly from one place to another and to have meetings in that other place, it's entirely up to you to figure out what that means in terms of you scheduling something at 3 a.m. there or here, or what it is. So my test for true artificial intelligence is one that makes time zones go away.
The last program will be able to seamlessly navigate both my schedule, your schedule, Joe's schedule, and the time zones and everything else. That's when we'll have the last program.
Particularly for travel. God, it's like,
Absolutely.
I'm going to Dublin, Ireland in a few weeks, and I look at my calendar and I'm having dinner at like
3
10
a.m.
in the morning. But I'm really like, oh God, that's mind blowing. Anyway, so that's my test because it's the most simple thing in the world. It's like time zones. It's like scheduling. Shouldn't be such a mind warp trying to figure it out.
And now, so I'm in a really interesting spot because I think I'm more similar to you, Dad, in terms of that technically I'm not that interested by programming. The programming itself, I'm doing this because I want to see how far I can take my prompting skills to see whether I can do it without learning too much programming. And so far I've been actually very successful compared to 10 years ago.
Before you keep going, I need to say to Joe, Stuart is now calling himself AI whisperer.
And what have you done to earn that title?
Well, so this is the most interesting thing. So I worked at this company called Invisible Technologies, and Invisible Technologies was a core part of the success of LLMs in terms of programming. So there were a bunch of programmers. So there was a bunch of programmers actually creating the infrastructure to help OpenAI did what they do. Then there were also a bunch of human beings who were just outsourced business process who were just viewing what the LLMs were doing. And then, because I don't know if either of you noticed this, but GPT-2, the thing that got Elon Musk scared about where LLMs were headed, was also sort of psychopathic or sociopathic. Like it would make up stuff. You could get it to give you a nuclear bomb. It could do all these things. And so these big companies, these foundational LLMs had to basically steer it so that it wouldn't do those types of things. So it wouldn't seem ludicrous. And so a bunch of humans basically did that through rote, just like supervised learning and things like that. So this was a company that really knew what it was doing with the AI to create the LLMs. I came in there and the LLMs just fit. Like, I think it has something to do with my linguistic skills, but I was able to navigate these LLMs with no training. I just knew how to do it with my language abilities. I knew how to get the LLM to give me what I wanted. I realized very quickly that not everybody inside the organization had that same intuitive grasp. And I've now found other people here in Buenos Aires in person who have that same intuitive grasp. And it feels like I'm horse whispering, but with the language, the linguistic ability of human beings that have been instantiated through linear algebra inside of these LLMs. And so that's why I call it an AI whisperer. And actually this last week, we took 30 people, 30 non-technical people and about 7 developers. And I shared them my method for how to get a AI wrapper, i.e. an API to the OpenAI API, get them to build a fully functioning development side. So I still haven't gotten to the point where I can reliably get a production level app on the web that uses the AI inside of the app. But I was able to share this method, and 80% of the people at that workshop who had never coded before walked out of there with a fully functioning app. And that's what I mean by an AI whisperer, basically, that can intuitively grasp the prompting. And there's a way to teach it as well. That's the whole AI whisperers.
Just like the term whisperer comes from horse whisperer, where a human being communicate with a horse in a way the horse seems to understand and respond to. So the LLM is the horse.
So
I don't know if this is a fantasy. Yeah, I don't know if this is a fantasy that Stuart's pursuing, that he can actually write apps without actually knowing how to program. That's like a pretty mind blowing.
Yeah.
And I go back to when I started in the personal computer industry. This is what fascinated Stuart is, I was an English major and I'd worked at Inc. magazine, and I learned about VisiCalc and Dan Bricklin and Bob Frankston and all these guys. And then I had to leave Inc. And so then I started getting fascinated by this. And I remember going around and asking people and go, so, okay, so there's like this computer and it's got hardware and it's got software. And what's the difference between the hardware and the software? What's this thing that's in the middle that has software embedded in the hardware? So, well, I can say that now, but I didn't actually understand at the time. And every time I'd ask somebody, I'd get a slightly different answer. And I'd sit there and go, oh my God, this is so confusing. That was 1980. And that's where it started. Now I can kind of talk the talk.
So, and this relates to
Whisper.
yeah, well, yeah, and this relates to what I want to understand from Joe is like, because Joe, you're technical, you're able to program the computer. So in the sense that I may be an AI whisperer, you are a programmer. You're somebody who could actually get that base machine to do what you wanted to do, and from the very beginning. Is that accurate? And like, what did it feel like? And what did it look like?
Yes,
Dad go, yeah.
Absolutely. I could do that, but it was frustrating and tedious.
Yeah.
And sure, I learned how to do that. I started programming on an IBM computer, which hasn't existed for probably 40 years, in a candy factory next to the campus of MIT, and use that to help pay for my bills. But boy, it was tedious.
And did you have any teachers who were teaching you how to do it? Or did you just go on your own?
No, I just sort of figured it out, or maybe there was a manual. I sort of lost track. That's a long time ago.
Yeah.
But certainly by the late 60s and early 70s, people were talking about trying to make things software easier to build. And there was a well-known fellow named James Martin who wrote a series of books on it. I think it was ex-IBM, and I don't even know if he's still alive now. But and he wrote a lot about how to make things easier. Once you had in your mind the idea of what the computer was supposed to do, why did it take outside experts and a long period of time, and then to finally get what at least they thought you wanted. And there was a little ditty at Progress Software that I started, where the last two stanzas, the last two lines were, "That's just what I asked for, but not what I want," which meant that after all this effort, you had to go back and start all over again, because what you created was what you thought the person wanted. It wasn't what they actually wanted. And so that long delay and slow cycle time of creating applications always drove me crazy.
And this is what I love, because what you just mentioned is still the case. Like LLMs, all this stuff. It's like it's nobody knows what they want. That's the whole problem, right?
In fact, the whole
part of the problem is that people don't know what they want, which is why a fast cycle time is important. In other words, the quicker you can give them back what you thought they wanted, the quicker they can say, no, that's not quite right. What I really want is this other thing. So, that's why they talk about the IT being such a bottleneck, and it just takes so long to get from a user saying, look, I want something to keep track of the following for me and produce the following reports, or let me, query the status of whatever it is, orders, items, whatever. And before you actually say, well, okay, I think this is what you wanted, or this is what you told me you wanted. There was this whole effort of specifying things more exactly. None of that worked. You first write it down, and then it just, in the end, you never produced. It was like that little ditty I cited, you never produced what the guy wanted. Or the other thing that would happen was, yes, you did what I wanted, but now that I see what it can do, now I want these three other things. So software has always been, despite the word soft, you think hardware is hard and
Yeah.
software is easy, right?
Yeah.
Nah, it's the other way around. The hardware keeps getting better and better, and the software is still a horrendous bottleneck.
Still frustrating as ever. Yeah. Go for
So,
it.
so I told Stuart, I think when we talked last week, I mentioned the book Mythical Man Myth.
Yep.
And,
Yes.
which has been kind of like my core understanding of software, which is, and it was situational because IBM needed a new operating system for a new generation of hardware. And they spent years working on it and it failed. And this guy, Brooks is his last name, I can't remember his first name, but they put him in charge and he completely revamped the whole process they were using and managed to produce like the new operating system in less than a year. And the sort of fundamental thing was that he understood that software required people to communicate with each other. And the more different communications you had going on at once, the harder it was, right? So he concluded that you had to have small teams. It wasn't a matter of man hours of programming, which has been the previous way of thinking about it. It was
Where did
a
that
matter
come
of
from? Where did that come from? Where did the idea that you could just throw people? Was it the military? Was it World War II?
No, I mean, it's factory automation.
Factory.
Basically.
Yes. Yeah.
So they viewed it as a factory. You just hire, thousands of programmers and you tell them what to do and they do it. But that actually collapsed. And it collapsed again when Microsoft tried to do it. And they had to go through, and like 30 years later, they had to go through this, no, even longer, 40 years later, they had to go through the same thing. So this, in software, the key, I'm not a programmer and I can't wrap my head around that, but I get the idea that human beings have to communicate with each other to accomplish stuff. So, and there's sort of an optimal group, which is somewhere between 8 and 10 people that can maintain communications around a particular problem and be effective. So the way you do it is you break it down into small groups and then they have a hierarchy that figures out how to integrate everything.
Brilliant.
How's that sound, Joe?
That sounds about right. The co-founder of Progress used to have to quote him, it was, well, if we really want to slow down this process or this effort, well, we can just add some programmers. That'll slow it down because it would take so long to bring them up to speed to where they understood what the heck they were doing. So a small team with other developers sort of arranged on the outside, but the small team focused on the kernel of what it is you're trying to do has generally proved the most effective.
Okay, you mentioned a word there.
The tipping point in this case is where the amount of communication exceeds the amount of programming time.
Yes, meetings.
You're spending more time communicating than actually writing the software.
Yeah. Kernel, you mentioned kernel, and I don't think you were meaning this in the software sense or the hardware sense about it.
Well, not in the operating system
Not in
sense,
the operating system,
but the most fundamental parts of whatever it is you're trying to build, which if it's fairly complicated, fairly complex, and then you figure out interfaces between that and the rest of what needs to be done so that other small teams can do the other stuff.
So let's talk about that.
There's a concept in operating systems. Every operating system has a kernel, which is a really small part that controls what's going on in the operating system, and then the surrounding. Now it's going to the infinite with like the Mac OS as it is right now is actually originally Linux. The kernel is surrounded by massive amounts of stuff. I don't know how the hell they keep track of it. That's the thing that amazes me is how the hell does Apple keep introducing new versions of the operating system without screwing up? Because every other operating system vendor has always inevitably gotten to the point where it just collapses and they can't figure out what to do with it.
Like CrowdStrike, like the CrowdStrike thing that happened.
CrowdStrike's a whole different problem.
Whole other thing. Okay.
More about how people update their software.
Okay, so let's not go into that. But so me and my dad have been going through to the last week. We kind of we keep on ending in this place where Dan Bricklin, VisiCalc, Lotus Notes, sheets like a spreadsheet seems so fundamental to the software versus hardware thing. Joe, is that right? Is it all with the spreadsheet, or was there something else? Like you mentioned, you were trying to get these computers to do these things, specifying the things that we really want out of these things, querying the status, the items, producing the following reports. Like what is it, if you want to talk to that spreadsheet problem, you feel free to, but what is it that Progress Software really helped with if you want to go down that path? Like what were you guys doing for your clients?
Well, I'm lucky enough to actually work with Dan Bricklin now at another company called Alpha Software, which is essentially trying to make it much easier to build mobile applications, including dealing with a situation when you're out of range on your mobile device, you don't have any access, any internet access at all. But um, the spreadsheet was so easy to understand because it was visual. I mean, the first one, the one that Bricklin and Frankston built, was called VisiCalc, which was a darn good name. You know, many people in the industry have only a vague memory of 1, 2, 3 and no memory at all of VisiCalc. Okay, so they really only know Excel. But because it's such an easy to understand tool, I mean, basically, the first time you see a spreadsheet and get it to add two numbers together, you sort of figured the thing out, right? So it is more or less programmable by the end user. So the end users in their desire to accomplish things, keep track of things, and so on, often use a spreadsheet as basically a programming environment in which they can develop applications. The spreadsheet really wasn't designed for that. There's a joke in the industry: what's the most common database? And the answer is a spreadsheet.
Yeah.
But a
Still
spreadsheet
today
really wasn't meant to be a database. It doesn't deal with a whole bunch of issues like several people accessing at once. Imagine a spreadsheet and everyone's putting information and getting information out at the same time and sort of stepping on each other's work. So the spreadsheet, on the one hand, gave people an idea of what computers could do, and on the other hand, sort of got in the way of doing more sophisticated work because it just wasn't the right tool for the job.
Yeah. And this is still today, like at the last company that I worked with.
Oh, absolutely.
Yeah.
The company that I'm now working with, Alpha, the typical thing they run into when they talk to a potential customer is, we're doing it today with a spreadsheet.
Yeah.
Okay. But it's got X, Y, and Z problems.
Yeah.
And, can you supply us with something that's almost as easy to create the application with, but deals with all these issues?
Yeah. What do you think that?
And there was a time when spreadsheets got, trying to remember the term, but there was a company that came along and figured out how to kind of store the data on servers from a spreadsheet, but continue using the spreadsheet as the interface. And they were able to turn data around in 3 dimensions and, visualize what you were doing. Arbor software back in the late 90s became very successful and ended up getting, but
there have been a lot of attempts to sort of marry the simplicities of spreadsheets with something that deals with some of these issues having to do with multi-user access, checking the data before you allow it to be entered, all this kind of thing.
I mean, that feels like Web 2.0 basically in an explanation, is that like Airbnb, Facebook, Uber, all of these things, they're basically just managing huge amount of data with a whole bunch of users, all using a specific pathway in a GUI inside of a web browser or mobile app GUI that essentially helps them navigate. And this brings up to the question that I wanted to ask was, because programmers don't seem like they're very good at organizing information in a visual way. And that's where designers and UI experts and all of these other people that seemed really important, because I remember it still in the 1990s, like it didn't look good. None of those things looked good. They looked kind of like a programmer you'd expect from a programmer. And then designers came in. Yeah. Now you go on Facebook or you go on Airbnb, and Airbnb was known for this, is that it just looks very beautiful. When did that start happening, in the 90s or wherever? When did you guys start to notice these?
Well, so the underlying thing you're getting at, which is building multi-user business applications, right? The most well-known one were airline reservation systems, which have really existed since the 70s. but the interface was, talk about clunky.
Yeah.
The interface was horrendous. I think I remember sitting with Stuart once and trying to use, so the one that American Airlines sponsored, Sabre, okay?
Saber.
And
Yeah.
they came out with this thing called Easy Sabre, which was supposed to be accessible to the end user.
Yeah.
And you could access it on your screen. I don't know if this was before GUI or after GUI. I sort of lost track of that.
Oh, wow. Interesting.
But I remember sitting down with it. I have a vague recollection. I sat down with it with Stuart, but perhaps it was another brother. And, we tried to actually book a reservation on
Yes.
Easy Saver. And it was just impossible. It was ridiculous. I remember another time, now that I'm thinking about it, is when the other brother Ian and I tried to book something over the French system that
Right.
actually in some ways, quote, invented the internet in the early days, because they had a way that you could access a central computer and
Through
try
your
to book
television.
railroad. Excuse me?
Yeah. Through your
I
television.
tried to book railroad reservations, train reservations. And again, it was very hard to do. So what's evolved over time is we went from character mode, I don't know if anybody can remember this, but character mode interfaces where you sort of type things in a line at a time and hit a character turn, and then the computer would respond with something, to on mainframes, typically you were connected to a mainframe, through several generations, which first involved quote, client server, which was a little bit of a misnomer, but anyway, not very useful. But that was sort of a 90s phase. And then, of course, the internet came in, and all this effort, which had been going on since the 80s or maybe even the 70s, to make it both easier to access the application and not require so much sophistication on the part of the user, not 3 months of training in order to use this airline reservation system, to where the end user could do stuff by themselves. So it's not really Internet 2.0, it's sort of dealing with people 3.0 or 4.0, we had at Progress, we had several phrases for this. One was turn around the terminal. So you walk up to a airline desk, you walk to go check in, and the terminal faces away from you. It faces towards the operator who's been trained on how to use it.
Yeah.
For 3 months or whatever, and then another 6 months of experience before they really know how to do it well. And our focus was to turn that around so that users could do things themselves. And that's been an ongoing effort in the industry, to just get rid of the intermediary people.
Since
right? The
we're
way you used to
talking
make
about it.
airline reservations was to call, or you called the hotel, or you did it all on the phone, and then I don't know, maybe there was some sort of paper confirmation that you got in the mail a few days later.
In fact, airline tickets used to be cash. The equivalent of cash. If you lost your airline ticket, you didn't have a reservation. But since you mentioned CrowdStrike, I flew that day, and I went to the Santa Fe airport, and all the systems are down, all the screens are off. They're all got the blue screen of death. Please start your computer, and they're in chaos. They have no idea what's going on because all of their systems are down because of the CrowdStrike problem. And so I watched them. I stood in line. I made sure I was the first one in line, and I watched them trying to check us in. And they're on a phone with the app,
Tech support,
their app, on their mobile phone, and the guy's talking to the guy, trying to figure out how to be able to say that I'm actually there and about to get on the airplane. And there's a little bit of let's just get these people on the airplane and take off. It's so it was so that was just a really interesting experience.
This is part
But they got you on the plane.
They got me on the plane. I only left 2 hours late. And
That's impressive.
The plane that I was
What about your connection?
The connection was 3 hours late. So I got to where I was going. I was just 4 hours late.
So this is part of why we started the show, is because both of you have these memories of the world that existed before the world that I grew up in, and now the current generation, Adam and Ava, are just they don't even understand the world that that I live in or that I grew up in. And there's so many layers of abstraction that have been built on top of this kernel of computation, and it's so hard to go back to understand what it was like. And then now we have this new layer of computation that seems very important, that's going to change a lot of it. And so, but is it easier now? Like, it sounds like what you just mentioned, Dad, with the CrowdStrike, like it feels like there's this, is it easier? Is it actually more convenient than just calling
What you're
a human
talking
being?
about, what you're referring to is the legacy problem, right?
Mhm.
There are multiple generations, and at some level, there are mainframes still there in the system
Yeah.
somewhere, right? That are still being maintained from 40 years ago. I don't know, maybe 20 years ago, but there's always this generational layer upon layer upon layer of old stuff and new stuff. And this is the problem in organizing all this stuff, is you can't leave behind the old stuff, because everything will fail. This is kind of what happened with CrowdStrike. Is it was actually an update problem. The way that they distributed an update to the system, they missed something, and it turned all the computers off and didn't turn them back on. That's the problem, right? That's like, how could artificial intelligence have figured that one out?
Interesting.
So the conditions are incredibly complicated because of the legacy problem. The fact that you have all this other stuff that's already been built and is operating, and how do you change things over time? And there's a tendency to always think that the new thing, the shiny object, is the cool thing, and you kind of forget that there's somebody in the back there trying to make all this stuff work. So there's this tension, and it's very similar in programming. This tension between the amount of time it takes to communicate in order to build a program versus what the benefit is that it creates. And this is I find this fascinating, to be honest. That systemically, there's no way to make it perfect. There's a way to make it less annoying or less something, but it's never perfect.
Yeah, and that's really interesting. So, and large systems, no way to make it perfect. There's this. It also relates to something I've been sort of stirring the pot with my online posts, really pissing off the nerds or the programmers who are used to the way the things that have been done before. If you both remember the story I told earlier of getting 30 non-technical people to walk out with a program working, not having written any code, just using natural language in order for the AI to code itself. So I explained this to the programmers, and the programmers are like, this is going to be dystopia, because really what AI is giving right now, and this is what I meant in the post, it was misunderstood, is that it's giving programmers this ability to write a huge amount of code that they can verify very easily because they have this background. I, sitting there dinking around, having the AI code things, I just create this web of mess, and as soon as something goes wrong, I have no idea what I'm doing. And so that's interesting. That may change in the future, but they all tell me, like, and so now there's going to be a really interesting problem, which is that AI now changes the incentives. And I had a programmer tell me this. They're trying to hire people. It makes way more sense for them to hire a senior programmer who already knows what they're doing, who can use AI to code for them and verify that. It makes them almost no sense to hire a junior developer. And the way the programming worked for the last 20 years is that junior developers would be hired because they didn't have AI to do these basic dumb things that they already know how to do that just take a lot of time. And so now the reason for companies to hire junior programmers is actually collapsing, basically. And so there's going to be a sort of a really intense gap here where it's going to be really hard to get that senior level understanding of programming.
It's not just programming. It's in almost every profession, right? Because of my involvement with Meow, there's this serious concern among creators that computers will just start creating everything. And even if they don't create everything and they don't have, the creative spark, you take out all of like 80% of the jobs that lead up to being able to deliver a creative work. And lawyers and even doctors. I mean, eventually, computers will be figuring out what's wrong with us. And so it's not just programmers, but it is interesting that if there's 100 million programmers out there, I don't know what the right number is, but we won't need more than 20 million.
Yeah, interesting. But we will need entrepreneurs, and this is kind of like where you guys can.
Well, actually, let me insert one other thought here, which is, in the world of programming, originally, in order to program, you had to know how to essentially do binary code, which is like control the zeros and ones right there at that point, and assemble it's called assembly, but no, that's a different issue. But assemble the ones and zeros in an order that would make something happen, and then they have programming languages on top of that. But in order to have a programming language, you have to compile it into the ones and zeros, and so there's like all of these layers still exist, right? And so the issue is, for the senior programmers, do they understand how the machine works well enough to actually manipulate it? Or are they operating at a higher level programming language? And we're not even talking AI here, that they don't understand how the computer's working. And is there a delta between the ones that do understand how the computer works and the ones that are operating in a programming language at a higher level?
And let's turn that to Joe. I would like to get more understanding of those initial layers, because you essentially learned all this thing as the layers were being built. And like, do you still have an intuition of how these computers work? Like, is that still part of what drives you every day?
Yes,
Yeah.
possibly excluding the graphics processors that drive AI, which I do not understand very well. But yes, I can visualize everything from, the thing that the command or the request that a end user might put in, all the way down to how that would get down to the hardware. That's not that hard to understand. Once you've done a few examples at the different levels, you sort of get it.
Okay.
So, and most of here's how this works. Most of the time you can stay at the higher level.
Yeah.
Occasionally, a problem will be so, well, it'll have such high performance requirements or something like that. You got to go down to the lower level and code in assembler or machine language or whatever you want, that particular piece, and then somehow integrate it with the stuff that you've done at the higher level. That happens occasionally. It happens less and less often because the hardware gets faster, and there's just less need to tunnel down into these lower levels of the technology in order to tweak something in order to make it go fast enough. It still happens a bit, but not as much as it used to. But it is useful to understand all the levels. How useful that will be in the future? I mean, for example, your students or whatever it was that you brought into that room, how much did they really need to understand, which included some system analysts, right? You said, or programmers, 5 programmers and a dozen students, something like that. How many of them really needed to understand how the LLM works underneath in order to do anything? Answer, not many. I can see you shaking your head. So most of the time you concern yourself with the level that you're facing, and just allow that some magic is happening underneath that kind of makes the whole thing go. And in rare instances, for example, in working on an operating system, or maybe this is where CrowdStrike messed up with their security software, you're at very intricate coding level, down deep in the bowels of the technology, manipulating bits around. And that's where you can make a lot of mistakes, which is an argument for doing things at a higher level because it's more reliable, right? Maybe you lose a little efficiency.
Oh, interesting.
But it's not only simpler to do, it's also the result is more reliable. You're not going to have weird little glitches that cause the whole thing to fall apart.
Okay, that's really interesting. Yeah, go for it.
So there's another level that you haven't addressed, Stuart, which is that in the hierarchy of programmers, and this is how companies, because I invest in tech companies, they're organized, there's a different role than the person who runs programming, which is usually called the VP of engineering, which is chief technical officer. And there is a role, which at least in software, called software architecture, right? And being an architect in technology does require that you know it from the ground up through all the levels in order to be able to say, well, this is what we should be doing in 2 years, and then communicating that to the engineering group. So there are very few architects. Architects are extraordinarily specialized, and so like an architect at OpenAI,
Yeah.
he's way out there, right?
Yeah.
Understands transformers, natural language, neural networks,
Yeah.
plus GPUs and how the hell they produce these things. It's, you know, in order to be able to say, well, this is what we need to do next. So the difference between 3.5 and 4.0 or whatever you call it at OpenAI is what it is, right? Somebody had to know that in the past and then make it happen. And so they're, you know, from junior programmer who's, you know, cleaning up messy code and, you know, maintaining, to architects. There's this huge span in between. And kind of the question you're asking is how many of those levels get wiped out ultimately.
Yes. And this brings me to mind, because it's not totally related directly related to that, but I do believe it is related. Why, Joe, did you get so interested in starting a company, and what did you learn about people in this? Because you guys both started when it was in its infancy, this whole complexification. You've seen it all grow throughout, you know, decades now. Joe, what interests you to get you hooked into this?
Basically the complexity of programming. Maybe it's the fact that I had trouble with it. I thought, wow, this is a big problem. It was just so painful to code so much of this stuff, or when I wanted to change it, to have to go in and tweak something in order to get a different effect. And I had to understand all that. And it just made no sense to me that I had to be sort of in the middle between the technology and the person with the need to keep track of some project or whatever it might be, some financial aspect of a company or manufacturing or whatever. And, you know, to insert this person, or as Stuart points out, maybe multiple people, between what the person wanted on the one hand and the actual implementation of the solution on the other hand, that just struck me as archaic. Now, because of the way hardware is built and sort of the constraints that hardware lives under, you know, it's not possible to build it directly into the hardware, the simplification I'm talking about.
Interesting.
So you have to have a layer between the hardware and the higher levels where you can do things and translate them into the language that the hardware understands.
Yeah, interesting. And that's where these multiple layers of abstraction, and there's a new coding language that a lot of the software nerds that I talk to called WebAssembly, which basically allows you to do that all in Rust, which I believe is some sort of functional programming language, but allows you to it's like a replacement for C, that people who I don't understand enough to speak intelligently enough about it, but it's got a bunch of programmer mind share because it's not Python. It's not being compiled. It's like directly to assembly, I believe. It goes assembly, WebAssembly. Yeah, it's like at that layer where they can manipulate the hardware in ways that C fails to do. I still don't understand enough of it. But
well, the fact that you don't understand it is interesting, because one of the frustrations I have with the programming kind of profession is that they fall in love with one or the other programming language or you know, class library or whatever, and they're really not dealing with the fundamental issue, which is somehow you have to make this easy enough for non-programmers to deal with. They never deal with that issue. They like this new shiny object, this new development environment, programming language, whatever, that are constantly being invented. And my view is those don't really solve the problem, which is to bring the user and the development environment closer together, so as to shorten that cycle of application development.
So what did
So
you?
I'm sitting here. I'm saying had to look that up. Never heard it before.
Yeah.
And on Wikipedia, WebAssembly is named to evoke the concept of assembly language, a term which dates to the 1950s. The name
If
suggests
not before.
The name suggests bringing assembly-like programming to the web where it will be executed client-side by the website users command, blah, blah, blah. Gets on.
Yeah, I do not see that as progress, but you know, maybe from the mindset of a developer, that might be wow.
Yeah.
I look at it and I say that we're probably going backwards. I mean, Stewart's quote of the word WebAssembly deriving from assembler
Yeah.
kind of says it all to me.
So,
Yeah,
but
that's on chip level. So let me
Yeah.
try another thing on you, which may distract us. But I'm fascinated by the concept of state. A stateless system means that it doesn't depend on any conditions to operate. And so a lot of people look at Facebook and go, you know, it's like, it's not that big a technology, right? They probably don't have a big tech stack. And yet, the thing that they've done, which is totally remarkable, is they maintain state for every single one of their daily active users, which is close to 2 billion people. So across the world, any one user can interact with Facebook, and all of the information that's relevant to them, both coming out to the user and going back, is maintained in real time.
Whoa.
So when you press a button and put the like thing up there,
Whoa.
it goes distributed in real time to everybody else that's connected to that user. That's like really amazing. And Twitter was doing kind of the same thing, but we're never really good at it. So Meta now, which owns Facebook, Instagram, and WhatsApp, all of those apps operate in real time in a stateless fashion. And it's like, that's a really significant. So they have to have serious nerds inside of Meta to be able to pull that off.
For sure.
Right now they're like distracted with LLMs and virtual reality, but it's a remarkable thing what they pulled off, that they managed to go from being this stupid little company that did stuff for colleges to having this massive real-time stateless system.
That makes it make more sense why they went after virtual reality, because that idea, like that idea of what you said is like a state, keeping state, and then obviously they want to,
and then doing it visually,
yeah,
right? Not just on a computer screen, but doing it here. And or the thing that's really interesting, a lot of people are focused on, is they got these Ray-Ban Meta Ray-Ban glasses, kind of somewhere here, you know, that are internet connected and have a little LLM interaction. So you could say, look at something and could look at the screen and go, so who am I talking to? And it'd say, it would identify who you are and tell me up here in my ear. And you know, the next step is to see it in the glasses, which you can't do with the Meta, but they're working on it, right? So that's the future of AR, where we're always connected. You know, I don't know if that'll work or not, but that's a different.
Yeah. Well, Joe, I want to ask you a question about, I had asked it before, but it's like, what did you learn? Because you kept on, you keep on talking about how it's not, the technology isn't that important. It's what the technology does for the end user, and always focusing on that end user. And you hear that reiterated a bunch by the Y Combinator, talk to users, talk to customers, do that type of stuff. What did you learn about people in this journey, either as the end user, or you also built this organization where there were a lot of people inside of the organization and you had to navigate a lot of people? What have you learned about human nature in your career?
That's a pretty big question.
This is why Stuart's such a good interviewer.
I think that, you know, overall, I maintain my faith in human nature. Most people want to be challenged, want to do well, want to produce good work. I mean, and it's really trying to remove the barriers and, you know, the sort of corporate politics or whatever, from strip that out so that people can be excited by what they do and produce good work. I felt that pretty early on. That hasn't really changed. You know, in terms of the customers, I think Jobs' disdain for market research is something I completely agree with, that basically the potential customers, the marketplace, whatever, they're not going to really, you can't go out and ask them, do you want XYZ? You have to produce XYZ, hopefully without bankrupting your organization, and show it to them and watch their reaction. So I think that customer feedback can work for incremental improvements, getting from Rev 3 to Rev 4 of some product. It doesn't work for the initial visualization of what the product should be. That has to be some combination of, entrepreneurs and technical people that work together to create it. And I've seen it again working with Dan Bricklin at Alpha Software. Is he had a vision for what the product should look like, and even though I was kind of fuzzy on what he had in mind, it was like, okay, I have enough confidence in this person, who after all created the spreadsheet at a very early time in the computer industry or in the IT industry. Let's see what he can come up with. And then as he produced something that was sort of at a prototype level, the rest of us could buy into it. And now that's the main focus of the company.
So you said something about corporate politics started to show up. This is something that fascinates me. When did that start happening at a Progress? Like how many people start happening at?
So two things cause it to happen. One is you have a larger organization. And the second is, as long as you're growing very rapidly, everyone's job in that organization gets bigger just as a result of the growth of the organization. So even though the title doesn't change, you end up with, 50% more responsibility. Why? Because the company grew 50% in the last year. It tends to show up when the growth slows down.
Yeah.
And then suddenly someone in the middle of the organization is thinking, well, I can't just get ahead by doing my job that's getting bigger each year, doing it well. I need a promotion to take over that person's job. That's when I really noticed.
Okay, and you said something that led me differentiate two things that I've been struggling with. There's the politics, which has more to do with scarcity, and I do imagine that exists. I've never been in a declining organization, so I don't know that. But there's also the bureaucracy layer that just happens because of coordination costs. That's the thing that I'm.
Yeah, and within Progress Software, the company I started, I was well known as the anti-bureaucracy guy.
Yeah.
I just hated that.
Yeah.
And for all the reasons that you're alluding to, which is that it would just kind of, someone had to check some corporate policy guideline every time they wanted to initiate something. Well, that just put sand in the wheels of the organization, it's less responsive. And so
when did that show up?
My attitude was hire the right people. And, if they've got issues, give them some guidance or let them ask what should be done. But I was not a big fan of, policy and procedure manuals that are this thick.
Did you ever work in an organization like that just got really big?
Well, IDG was big, but it was extremely distributed. And so it had very little bureaucracy, so little that people got frustrated. But what brings this to mind is one of my favorite books called No Rules Rules. And this is written by the co-founder.
I should read that.
Yeah. Well, here's the funny thing. And so it was written, I don't know, probably 6 or 7 years ago, something like that. You can look it up. And it's written by Reed Hastings, who was the CEO of Netflix and took it from, being a renter of DVDs to what it is now, including all the way through multiple generations. Like they introduced streaming and it didn't work so well. And then they tried to separate the company and all these different things. And his fundamental point was, at least in a fast growing organization, you have to deploy trust. You have to trust your employees, and you manage your hiring processes to make sure that you're hiring the right people that can be trusted. And you have to deploy that through, because Netflix went from like 20 employees to 20,000. And so it was really interesting how he did. No expense reports, no permissions. People made their own decisions when they wanted to take vacations and, when they traveled, how they spent money. And if there were exceptions, they could fire. But so there was a different mindset. So then he wrote the book, and Netflix continued to grow, and now it's worth, I don't know, billions of dollars, a couple $100 billion, I think, and has a lot more employees. And he left the company. So you can't scale an organization that big having rules. They're back to writing expense reports and having approvals and doing all of this stuff that normal organizations do. And kind of no rules doesn't apply anymore. So what's really interesting is to read the book and then look at how the company operates now.
Yeah. Yeah, that's interesting. But in Apple, so let's go into Apple. What happened in Apple to make it still able to do what it does?
Okay, in that case, I am an expert, and I've spent a lot of time trying to figure out that question. Steve Jobs went through a variety of different experiences before he came back to Apple, including being at Apple and then building Next and then selling Next to Apple. And in the process there, he learned a lot about organizations. I mean, he was a very smart individual and he absorbed a lot, even if he was, a jerk. And so he instituted an organizational form which really persists, and Tim Cook has really optimized it, which is, and there's all different aspects to this, but one of the things he would do is have an annual meeting of the most promising people at Apple. Of course, he was the one to decide who was most promising, but he would really try to do that. So he would pick people. There would be 100 people that would come to this offsite, and some of them would be like programmers or chip designers or whatever in the organization, and he'd bring them all together. And some of them would be executives, and would create an environment where everybody wanted to be invited to that offsite, right? Everybody wanted to do the thing that would lead them to be picked by Steve Jobs to be one of the 100. And so he created this thing, which is a real meritocracy, right? At Apple, you succeed by doing really well. And Tim Cook has scaled this. And that, I mean, since Steve passed, they've created their own chip development organization. Yeah. They're doing better chip development than almost every other company in the world. NVIDIA's got a different scheme, but they're doing a very good job as well. And there's also, like, Amazon has their own chip development, and now Google has their own. So chip development is not much done by third parties anymore. It's now being integrated, and Apple's the one that figured that out. So in their organization, they have chip developers, they have operating system developers, they have application developers, they have distribution, they have market. I mean, the entire organization is an accumulation of all these different people. So how do you manage that? And that goes back to Steve's thing about the best 100.
So last question, how did Steve Jobs elect Tim Cook, and how did that power transition work? Like, how did it go?
Well, I mean, specifically at one point, it was clear Steve was going to die, and he knew it, and everybody else knew it. So he appointed Tim Cook, stepped back, and he appointed Tim Cook as CEO. Thing happened between the two of them. There was no board governance or anything else going on. And usually, and this happened at Microsoft when Bill Gates tried to hire a new CEO the first time, a guy named Jim Town, it didn't work. Right? Usually when people try to replace themselves and they're like big personalities or do this thing, they screw it up the first time. Amazingly, Steve picked exactly the right guy and died, and Tim Cook's been running it for the last 18 years.
And he's no Steve Jobs, but he's exactly what Apple needed after Steve Jobs.
Well, I mean, he'd hired Tim Cook, and they had worked together for a long time. Tim was a operations manager. He did supply chain and distribution and all of the operations of Apple, and he's brilliant at it. It's his core strength. So Steve kind of figured out that you don't really need to be Steve Jobs to run a huge organization like that. You need to be more like Tim Cook, who was already running most of the company.
Cool. Okay, well, last question, Joe, and we'll wrap it up. Joe, anything we should know about the early personal computing industry, the rise of the internet or the mobile, and how it relates to where we are today? Anything you want to add based on this conversation?
Yeah, exactly. Do you ask questions that are that large? I kind of have a model of how the industry's evolved over the last 30 or 40 years. I don't know how I can compress it into a quick answer, but basically one of my rules is follow the hardware. So, and this would be most recently, the example would be obviously the graphics computing chips
Yeah.
that now drive AI,
Yeah.
right? That the underlying hardware drives most of the exciting stuff that happens at maybe
Yeah.
a higher level.
Yeah.
So, in my lifetime, I've seen mainframes replaced by mini computers replaced by PCs, then the rise of the internet, which I think was driven by fundamental hardware changes, such as, if you are old enough, you remember that when you dialed a number, or maybe you touch tone a number, there was a whole bunch of clicks and so on as these mechanical connections were made that connected you to the person you were trying to call. And the replacement of mechanical switching with electronic switching, the replacement of copper wire with fiber optics, that's what enabled the internet. Sure, the TCP/IP protocols turned out to be the right set of technologies at a higher level to use in order to make it work, and that drove everything else out of the market. But it's those underlying hardware changes that ultimately drive the industry. So, watching where the hardware is going is important to understanding the future of the business. And again, the best example, recent example of this is the rise of the graphics chips as a way to implement AI systems.
I might have something for both of you that you might not have heard of. Actually, it'd be very interesting to hear if you have heard of it. Is Makimoto's Wave. So this has to do with it was Sony. A guy from Sony talks about how the GPU is an example of a generalized chip that does whatever AI chips do really kind of broadly, and it does it really with a lot of computation. But now the efficiency and the customization, now they're going to start customizing different chips. And this is Makimoto's Wave, where it goes from general to then specific customizations to all these little lines. And so the prime example of this is Grok, not Elon Musk's Grok with a K, but another company called Grok with a Q. And it is the fastest inference. And you remember I was talking about those AI wrapper things that we had people developed. We just got an API from Grok, and because of their chip does inference really quickly. So instead of waiting for ChatGPT or Claude to just like type everything out, it immediately does it instantly, like we've come to expect from any web application. And that's a great example, I think, Makimoto's Wave of what you just said.
So not that I have to have the last word, but Joel, remember when we started talking about the Evernet at Alsop Louis Partners, and Stuart and I have been talking about the Evernet, and I have a new Evernet theory, which is that the next evolution of hardware is already happening, but it's embodied in Starlink, and which enables you to bypass all of the terrestrial carriers, wired or wireless, and do communications entirely through satellites. And right now, a Starlink device, the smallest Starlink device, is about this big. But there's this thing going on right now, and I've discovered that everybody's on it, but I thought Apple did it first 2 years ago, which is they introduced SOS so that your phone could communicate in an emergency situation when you're, in the middle of nowhere with no cell and no Wi-Fi and no other connection. And turns out Samsung has it, and Google is introducing it now in their next generation of phones. And so I have this in my mind that there's going to take X amount of time to get what Starlink represents small enough to be a chip inside the phone, so that phones communicate all the time, everywhere, using satellite networks, and you don't need cellular anymore. So your phone will just work. It'll be part of the service that you're using. And when that happens, that restructures the entire communications industry. And of course, Elon Musk is leading in that, which is always problematic given what his strange dude he is. But the people that are designing phones understand this and will skip over Starlink and put it right in the phone. And so the key thing that's going to happen in the next version of iOS or iPhone, it's actually all in software, is that you'll be able to send text messages, iMessages, from anywhere through the satellite network. So it used to be just emergency calls, Now you're going to be able to text. And so what's
Mm.
next? You'll be able to send photographs. You'll be able to, and eventually it'll just be generalized in the phone. And Google and Samsung will see that that's what Apple's doing and everything, so maybe we'll, pull the rug out from under. SpaceX will still be up there though, watching all those satellites.
Well, that was really fun. Thank you both so much. And we'll get this published on Thursday. So if you're listening to this, tune in every Thursday on Spotify, iTunes, or YouTube.